Imagine a world where the electricity powering your home never loses an ounce of energy on its journey from the power plant. Think about devices that run cool, without any wasted heat, delivering every last bit of their potential. This amazing possibility becomes reality when we talk about zero electrical resistance. When electrical resistance is truly zero, something extraordinary happens. Electricity flows perfectly and indefinitely without generating any heat or losing power. This means that once a current starts flowing, it will continue forever, unimpeded, as long as the conditions for zero resistance are maintained. This amazing state is called superconductivity. It happens when certain materials are cooled below a specific temperature, known as their critical temperature. At this point, the electrons, which usually bump into atoms and create resistance, start moving together in pairs, called Cooper pairs. These pairs act like a single, superfluid particle, allowing them to flow through the material without any scattering or energy loss. It is a profound quantum mechanical phenomenon, meaning it is governed by the strange rules of the subatomic world, and it is completely different from just a very good conductor. Today, this technology is already used in powerful applications. For instance, in magnetic resonance imaging, or MRI machines, superconductors create incredibly strong and stable magnetic fields crucial for detailed medical scans. They are also vital for high-speed maglev trains, which levitate above their tracks, drastically reducing friction and enabling astonishing speeds. However, a major challenge is that most known superconductors requiring extreme cooling, often to temperatures near absolute zero, which is very expensive and energy-intensive to maintain. One fascinating property of superconductors is called the Meissner effect. This means they actively expel all magnetic fields from their interior when they become superconducting. This expulsion is why a superconductor can levitate a magnet above its surface, creating that visually striking floating effect. It is a key characteristic that sets them apart from merely perfect electrical conductors. The ultimate dream of physicists and engineers is to discover or engineer materials that superconduct at room temperature and normal atmospheric pressure. If we achieve this monumental feat, it would revolutionize power transmission, making our electrical grids incredibly efficient with virtually no energy waste. It would also enable a new generation of incredibly fast and powerful computers, more advanced medical devices, and entirely new forms of transportation, truly transforming our world in ways we can only begin to imagine.